Cartesian form. We all know what is Cartesian form. Cartesian form is nothing but x and y we are having here. So the formula is rho equal to 1 plus y1 square equal to 3 by 2 by y2. y1 denotes dy by dx, y2 denotes d square y by dx square. So if we are considering the first problem, we are having the find the radius of the curvature of y equal to e power x at 0, 1. So we have to find here y1 as well as y2. So we have to differentiate this equation with respect to x, then respect to x again. Secondly, we have to differentiate here. So we are having here two terms y and x. Y is dependent variable, x is independent variable. So we have to differentiate this. If we are differentiating e power x, again we will have e power x. So instead of x, we have to replace by 0. If we are having y, we have to replace by 1. This value of x comma y. X is 0, y is 1 here. So if you are applying e power 0 is value is 1. At the same way, if you are differentiating e power x again means again we will get here e power x. At the same way, we have to replace x by 0. We are going to get here e power 0 equal to 1. Then after getting your y1 and y2, have to apply our formula. Formula is 1 plus y1 square by y2. y1 1 plus y1 square equals whole power 3 by 2. So if you are replacing y1 and y2 value means we are getting here rho as 2 power 3 by 2. Next we have to move on next problem. We are going to consider here y equal to c cos h x by c. If you are having h means that is here hyperbolic function. So we have to do here dy by dx, that is your y1. If you are differentiating the hyperbolic function cos hx, we will get here sin hx. So we have to write here c sin h of x by c. If you are differentiating x by c means we will have here 1 by c. Then we have to apply our value 0, c. X value is 0, y value is c here. So wherever we are having x, we have to give 0 here. So sin 0 is 0. The overall term will become as 0 here. Next we have to move for y2. y2 is nothing but d square y by dx square. So if we are differentiating sin hx means again we will have here cos hx x by c. If we are differentiating x by c means we will have here 1 by c. This 1 by c and 1 by c will cancel. We are having another 1 by c here. Then we have to replace our x value and y value. Cos 0 value is 1. So we will have here 1 by c. So after getting our y1 and y2, we have to apply in our radius of curvature formula. This 1 plus y1 square whole power 3 by 2 by y2. So we know the y1 value, that is 0. y2 value is 1 by c. If you are applying here means we are getting here rho equal to c. This is only we have asked. We have to prove the radius of curvature of this equation is c. So we have done it. Next we have to move for the radius of curvature for logarithmic function. We should know how we have to calculate for logarithmic function.